Hello everyone, welcome to the 33rd lecture of the course Discrete-time Markov chains and Poisson processes. In today's lecture, we will solve a few problems on Poisson processes. So let us start. So here is the first problem. Vehicles arrive at a toll gate according to a Poisson process with rate 2 vehicles per minute. Fine. Now driver pays tolls of rupees 50, rupees 100 or rupees 200 depending on whether the vehicle is of low, medium or heavyweight category. So vehicles are of three categories, namely low, medium and heavy. So if the vehicle is of low weight category, then the driver pays a toll of rupees 50. If it is medium, then rupees 100, and if it is heavy, then rupees 200, right? Now, if an arriving vehicle is lightweight with probability 3 by 10, medium weight with probability 3 by 10 and heavyweight with probability 4 by 10, then find the mean and variance of amount of money collected in any given hour. So, every arriving vehicle is lightweight with probability 3 by 10, medium weight with probability 3 by 10 and heavyweight with probability 4 by 10. So, there are these three categories of vehicles: light, medium and heavy. Fine. And depending on the weight category, drivers pay different amount of tolls. So, the question is given, so if you are given a 1 hour span, what is the mean and variance of the amount of toll tax collected? Fine. Okay. Now, let N1T be the number of lightweight vehicles arriving up to time t. Let N2T be the number of medium weight vehicles arriving up to time t. Let N3T be the number of heavyweight vehicles arriving up to time t. So, again this is a case of Poisson thinning. So, the main stream is the stream of arrival of vehicles. Now, vehicles you can classify into three categories or three types, namely light, medium and heavy. So, basically the main stream of arrival you are splitting into three. So, in the theorem we saw we are splitting it into two, but see, if you can split it into two, you can split it into three. So, the way you can think of it is first you split it into two and then one stream again you further split, right. So, this is again a case of Poisson thinning. So, there we saw that if you have a stream of Poisson arrivals and you split it into two separate streams, then again those separate streams are Poisson processes with appropriate rates, right. So, here the probabilities are 3 by 10, 3 by 10 and 4 by 10 of lightweight, medium weight and heavyweight respectively. Fine. So, now I am calling N1T as the number of the counting process which is counting the lightweight vehicles, N2T the counting process which is counting the medium weight vehicles and N3T which is counting the number of heavyweight vehicles. Now, by the theorem on Poisson thinning, N1 dot is a Poisson process with rate. So, the original rate was 2, now the probability that it will be lightweight is 3 by 10. So, the rate of this splitted process will be lambda times p. So, it is 2 times 3 by 10 per minute. N2 dot will be a Poisson process again with rate 2 times 3 by 10 because it is also medium weight with probability 3 by 10, and N3 will be a Poisson process with rate 2 times 4 by 10 because it is heavyweight with probability 4 by 10. So, all these N1, N2 and N3 are again Poisson processes with rates 2 times 3 by 10, 2 times 3 by 10 and 2 times 4 by 10 respectively. Fine. And also Poisson thinning further tells you that these splitted processes are independent. So, N1, N2 and N3 are independent. So, in the statement of the theorem for Poisson thinning, we saw that we are categorizing events into two types, but here it is three types, but again 2, 3 does not matter. Basically you can do it for k types, because say first you divide it into two types, then one type you can further divide it into again two more types, so you can get three types. So, by successively using the same theorem, you can extend the result to k types of events. Fine. So, each arrival of each type of events will again be a Poisson processes with appropriate rates, and they will be independent of each other, right? That's what Poisson thinning told you. Fine. So, N1, N2 and N3 are independent. Now, let X be the money collected in a given hour. Then what should be X? Now, it should be, so the number of type 1 or number of lightweight vehicles that arrive in an hour and they pay 50, the number of medium weight vehicles that arrive in an hour and they pay rupees 100, and the number of heavyweight vehicles that arrive in a given hour and they pay 200. So, X is this. So, this again the unit is rupees. So, here everything unit is rupees. Fine. So, X is equal to 50 times N11, 100 times N21 and 200 times N31. That is because lightweight vehicles pay 50, medium weight vehicles pay 100 and heavyweight vehicles pay 200, and N11 is basically the number of lightweight vehicles that arrive in a given hour. N21 is the number of medium weight vehicles that arrive in a given hour, and N31 is the number of heavyweight vehicles that arrive in a given hour. Fine. So, the question is you need to find expectation and variance of X. So, now it is simple. So, for expectation of X, so it should be 50 times what is, so you know if it is a, so here your N1 dot has rate this and T is 1. So, basically N1 is Poisson 2 times 3 by 10, which is 3 by 5. So, that is N1. N2 is Poisson 3 by 5 again, and N3 is Poisson. So, you get 4 by 5, right. So, these are the rates, and since the time is 1 hour, so basically lambda times T is just lambda. So, and we know for a Poisson random variable the mean is equal to its rate or equal to the parameter. So, it will be 50 times 3 by 5 plus 100 times 3 by 5 plus 200 times 4 by 5, and finally you get it to be 250. Fine. So, this calculation you can easily do. Now, what will be variance of X? So, again variance of X should be variance of this quantity. This is where we will also use this fact that N1, N2 and N3 are independent, because then if you have variance of sum of random variables, it just becomes sum of the variance provided the random variables are independent. So, that we are using here. Again, we know that if you have a random variable which has Poisson lambda distribution, its variance is also lambda. So, what you get is variance of X will be, so now you for this, so it will be 50 square times variance of N11, which is 3 by 5, 100 square times variance of N21, which is this, and 200 square times variance of N31, which you get to be equal to this. Fine. So, the variance of X is given by this. Fine. So, again once you write down what X is, then finding expectation and variance is very simple. You use just the formula. So, for expectation it is even more simpler. For variance you need to use this additional fact that N1, N2 and N3 are independent, and using that you will get that variance of sum is sum of the variances. Fine. So, that answers both the questions. So, you see again the main concept that we used here is of Poisson thinning. Fine. Yeah. So, now if the unit is, so you are being asked about amount collected in a given hour. So, here T is basically 60. So, what you need is it should be N1 60, N2 60 and N3 60. Fine. So, basically the mean will be this times, so N1 60 will have mean 3 by 5. So, it will be lambda times T. So, everything will get multiplied by 60. So, this expectation of X is this times 60, and the variance, because again the variance will be lambda times t, so it will be this times 60. So, hope you have understood why the solution which I gave was initially slightly wrong, because the unit given here is per minute and you are being asked for something about a given hour. So, 1 hour is 60 minutes. So, it should be not N1 1, but N1 60, N2 60 and N3 60, fine. And then so what the net effect is, everything just gets, so in the expectation you get a times a multiplying factor 60. Similarly, for variance also you get a multiplying factor 60. That is because now all this will be, so here you know the lambdas, t is 60. So, if you have a random variable which is Poisson lambda t, then its mean is lambda t as well as its variance, fine. So, the correction is everything should get multiplied by 60, because here the unit is minutes and you are being asked about hour, fine, and 1 hour is 60 minutes. So, that is why I keep saying that unit is important. So, here it is good that I did this mistake, so that you will not do this mistake when you do it. You solve problems on your own, because here I made a mistake with the units, because the original rate was given in terms of minute and you are being asked about hour. So, the time is basically 60 units, fine. Okay. Now, moving to the next problem. So, customers come to dine at a restaurant according to a Poisson process with rate 10 per hour. Suppose that an arriving customer is female with probability 2 by 5. Now, if so, customers come to dine at a restaurant according to a Poisson process with rate 10 per hour. So, here the unit is per hour, and if you take an arriving customer, then that customer is female with probability 4 by 10. So, it is so the customer is non-female with probability 6 by 10, fine. So, if the restaurant is open for 8 hours a day and you are told 70 customers came to the restaurant yesterday, then find the probability that 30 female customers came to the restaurant yesterday. So, this is, you are being asked about some conditional probability. So, what is the information that you are given? You are given that yesterday 70 customers came to the restaurant for dining, fine, and each day the restaurant is open for 8 hours a day and the rate of arrival of customers is 10 per hour, fine. And also you know that a customer is female with probability 4 by 10 or with probability 2 by 5, fine. Now, so you are given that yesterday 70 customers came to the restaurant. Under this information you are asked what is the chance that, or what is the probability that exactly 30 customers were female among the customers who came to the restaurant yesterday. So, what is the probability that 30 female customers came to the restaurant yesterday, given that total customers who came to the total number of customers who came to the restaurant yesterday is 70. So, this is a question about conditional probability, fine. Again, so let us see how to solve it. So, let NT be the number of customers arriving up to time t, N1t be the number of female customers arriving up to time t, and N2t be the number of non-female customers arriving up to time t, fine. So, again we write down the counting processes. One is for the number of customers, N, which is NT, N1t is for the number of female customers and N2t is for the number of non-female customers, fine. Now, again using the concept of Poisson thinning, we get that N1 dot is a Poisson process with rate 10 times 2 by 5 per hour, and N2 dot is a Poisson process with rate 10 times 3 by 5 per hour. That is because the total rate is 10 and a customer is female with probability 2 by 5. So, non-female with probability 3 by 5. So, the rate of female customers will be 10 times 2 by 5 and the rate of non-female customers will be 10 times 3 by 5 per hour. And again N1 dot and N2 dot are independent. So that's what we get from the theorem of Poisson thinning. So again here the first concept that we use is of Poisson thinning. Fine. So again you see, so even the previous problem like vehicles arriving at a toll gate or customers arriving or at a restaurant, all these are very real life situations. So you have seen like while working with Poisson processes, we have solved problems which you see in everyday life very much. So these are all very real life problems that we are solving using this concepts of Poisson process. Fine. Okay. So what you are asked, so you are asked that given that N8 equal to 70, why N8? Because you are told that the restaurant is open for 8 hours a day. So your time here is 8 hours and the rate is given also as per hour. So the time unit is 8. So given that N8 equal to 70, that is because you are told that 70 customers came to the restaurant yesterday. You are asked what is the probability that N18 equal to 30. So the number of female customers who came to the restaurant is 30. Now conditional probability, we write down the formula. So it is probability N18 equal to 30 intersection N8 equal to 70 divided by N8 equal to 70. Now if N18 equal to 30 and N8 equal to 70, then that's simply that N18 equal to 30 and N28 equal to 40, right? Because if there were 70 customers, then if 30 were female, then obviously 40 were non-female, divided by probability N8 equal to 70. And now I write down the rates. So this is basically probability N18 equal to 30 and N28 equal to 40, but this intersection will become just product of the probabilities. That is because of this fact that N1 dot and N2 dot are independent. And what is the rate of N1 dot? That is 10, so it's 10 times 2 by 5, which is 4 per hour, and N2 dot is 6 per hour. That's why you have e to the power minus 4 times 8, because your time unit is 8 times 4 times 8 to the power 30 divided by 30 factorial, and similarly the second one as well as the denominator. Now if you just do the algebraic manipulation, you finally get this answer. Fine. So this gives you the answer, the probability that given that 70 people dined yesterday, the probability that 30 of them were female. Fine. This is the probability. Fine. Now let me just point out a more general fact from this calculation. So here it was 30. So in general, if you are asked to calculate what is the probability that N18 equal to some k given N8 equal to 70, then where like again if N8 equal to 70, so the number of female customers, so k will vary from 0 to 70. Now if you just follow the same calculation, you will see it will be just 70 choose k 2 by 5 to the power k times 3 by 5 to the power 70 minus k. So this particular thing is for k equal to 30. Fine. Now you can easily recognize this formula. So this is precisely the PMF of binomial. So given that N8 equal to 70, the probability that N18 will be equal to k, that has the same distribution as binomial 70 with success probability 2 by 5. Again, it's very intuitive because 70 customers came to the restaurant yesterday, and here you are trying to find out if that customer is female or not. So female is the success probability. So among 70 customers, what is the probability that you have 30 successes? So that's just the setup of binomial. So 30 is for the given problem, but in general if you have to say the probability that k female customers came, so it is just binomial 70. So n is 70 and p is 2 by 5. That is because a customer is female with probability 2 by 5. So that's the success probability. So if you are, so this conditional probability turns out to be the conditional distribution of N18 given N8 is binomial And so the parameters are, so if N8 is given to be 70, so that is 70, and the P parameter is basically the probability that a customer is female, right. So this is the general fact. Fine. So we have solved this problem. So we will stop here today. Thank you all.